So June 2021 MCQs we'll do from this paper. Which of the following is a fundamental particle? Proton is a baryon. Pion is actually uh, meson because it's a combination of quark and antiquark. Neutron is also a baryon with 3 quarks. Muon is there, which is a lepton. That is a fundamental particle. In early 20th century, scattering experiments were carried out by directing uh, high-speed alpha particles at the thin metal foil. Which of the following could not be concluded from these experiments? Like, which is not a valid conclusion from the Rutherford experiment? This is there because most of alpha particle passes through. There is a concentration of a charge in an atom, the concentration of a mass also in an atom. But B, we are not sure. The nucleus is charged. That is what Rutherford did not say nucleus is positively charged. He said nucleus contains charged particle that cause a deviation. And because overall atom is neutral, so if electron are around, so the neutral, the positive charge should be there at the center. But that is not the direct conclusion. That is like from the results, what Rutherford concluded was nucleus is charged. Neutrinos can interact with proton to create a neutron. Which of the following equation shows the process? So first thing, whenever you want to check the charge. Charge should be conserved. This is plus, here also plus. So here charge is conserved. Here plus, here my charge is not conserved. Here plus and plus charge is conserved. Here negative and positive charge, because this is neutral, so charge is not conserved. So either we can have A or C. Other options, because it's not conserved, so either A can be an answer or C. Now you can check the lepton numbers as well, or you can check the baryon number. It's up to you. Like start with A, because all conservation principles should be there. So when you check a baryon number, here baryon number is 0 because it's a lepton. This will be 1. Baryon number for positron is also 0, 1. This one, lepton number, baryon number 0, 1, baryon number 0, 1. So baryon number is conserved. Then we check the lepton number. For every lepton, the lepton number is 1 and NT is -1. So this is 0 and this is NT, so it will be -1 and 0. So lepton number is not conserved here. Here, this will be -1, 0, -1 and 0. So lepton number is conserved. That's why C is the right answer. So first, when you want to check the conservation, first start with the charge. Then you can check a baryon or a lepton. That order is not an issue, but start with the charge so you can remove the. And at the last, you can check if all are same, then you check the strangeness number. In 2015, a pentaquark was discovered. A pentaquark was made from 5, and a pentaquark form a baryon and a meson combination. Which of possible arrangement? Look, to be a meson, it should be particle and antiparticle. So 2 should be there, and 1 should be a particle, and 1 should be antiparticle. So this one is particle and antiparticle. So that's why it matches with option A. Because meson is combination of quark and antiquark, not particle antiparticle. I mean quark and antiquark. So only option in which we have one quark and one antiquark, that is option A. The diagram represents an arrangement to demonstrate the electron diffraction. A beam of electron is diffracted in a crystalline material. Which of the following single change would decrease the angle of a diffraction? Like, look, lambda is equals to h over mv. If we want to reduce the diffraction, like how the decreasing a distance between the sample and the screen. If we reduce this distance, like if we bring the screen closer, then as a result, what will happen? The angle will increase. Because if I place a screen here, then the overall angle variation, because so no, angle will not change actually, yeah, because we are changing both of them, because like say this is an angle theta is there. If I'm bringing the screen, like if I change the heights and the, so angle is not changing by mistake, angle won't change here. So decreasing a distance, the angle will remain same. Increasing the anode potential, if you increase the anode potential, it will have a higher, because kinetic energy is the kinetic energy is voltage into charge. If you increase the voltage, the kinetic energy will also increase. If the kinetic energy will increase, the wavelength will decrease. So that will increase the angle of a diffraction, because longer wavelength diffract more than shorter wavelength. Increasing a current in the filament, if you increase the current in the filament, like if there is more current, but the speed, there will be more electrons will be there, but it won't affect the value of angle, the theta. And if the sample smaller spacing is there, like if you reduce, because maximum diffraction, so this will increase the value of a theta. Maximum diffraction means like you will have longer wavelength or a shorter gap size. The coil of a wire is connected to a resistor as shown. The maximum flux density of a through increases steadily from 0 to its maximum. Which of the following single change would result in a smaller current? So if you want to reduce, because induced EMF depends on the rate at which we are changing the magnetic field strength as well. Increasing the area will increase the current. Increasing the strength of magnetic field will increase the current. Increasing the number of turns will also increase the current. Increasing a time means reducing the speed. So reducing a speed will decrease the induced EMF or amount of a current produced. That's why D is the right answer. A sphere traveling at a velocity v collides elastically, like there's no change in energy. The kinetic energy before, sum of kinetic energy before and after is same. Both sphere move off at an angle theta to the travel. The sphere have the same speeds. What is the speed of the sphere after collision? So because the collision is elastic and we don't need, because energy is a scalar quantity, so angle will not affect. So the sum of the kinetic energy before is equals to sum of kinetic energy after. So kinetic, this is moving, mass is m, moving with velocity v. Plus this is stationary, so 0. Then this will be, but the kinetic energy is half mv square, so 1 by 2 mv square. We'll write as 1 by 2 mv square, and we write 1 by 2 mv square. 2 will, m will take common, will cancel out m both side, and half also. So it means v square is equals to v square plus v square. Like this is a final speed. You can say like v1 and v2. But as I mentioned, they both, after collision, angle theta is there. Of the first sphere, as shown, the sphere have the same speed. The sphere have the same speed as each other. Like they recoiled with the same. Like this is a new speed. So this is a starting speed example. V is there. So v square is equals to 2v square. These two v's are different. So v square over 2 is equals to v square if we take a root. So v over under root 2 is equals to v. So the new speed will be v over under root 2. Is it clear, this one? Why? Because it's a kinetic energy, so angle does not make difference as it's a scalar quantity. So you just use the formula half m1 u1. You can use this formula half m1 u1 square plus half m2 u2 square is equals to half m1 v1 square plus half m2 v2 square, and then substitute the values. This will be half m v square because the initial speed is v, plus this is 0. This will be half, mass is m, speed is v1 square, or you can say x, but they move off with the same speed they mentioned here. They move angle theta. The sphere have the same speed as each other. Like this will be x square. This will also be half m x square. Half cancel out, m cancel out. So it will be v square is equals to 2x square. V square over 2 is x square, and then take a root. So v over under root 2 is equals to x. Like the new speed is v over under root 2. That's why we take B as a right option. Question 8. The diagram shows the two metal plates with a potential, and it's making angle to the horizontal. Which row is the electron is deviated? Which row of the table shows the change that caused theta to decrease? If we increase the voltage, the strength of electric field will also increase. So as a result, it will cause a greater deviation. So we should decrease, not double. Like if we increase the voltage, this causes greater deviation, so angle will be greater. But we want a smaller, the electron deviated through an angle theta, and we want to theta to decrease. So voltage should be half. And the strength of electric field should be minimum. So how is strength of electric field minimum if we increase the distance? Because we have the formula V is equals to ED. So V over D is equals to E. So voltage, because we want to reduce the strength, so voltage should decrease and the spacing should increase. Because so it will reduce the deviation or the angle. A proton travel at a speed v enters a magnetic field. A force exerted on the proton. Which of the following gives the speed of this proton? So the forces is shown. We have the formula F is equals to QVB. So force is 1.2 into 10 to the power minus 11. Q is a charge of a proton, which is 1.6 into 10 to the power minus 11, 19. V is the speed at which this is moving, and B is the strength of V is the strength of a magnetic field, that is 5 Tesla. So this will go there in division. So this will match with, because we need V is our subject, so this will go there in division. So C will be the right answer. Then the last question from this paper. The structure of a nucleon can be investigated using electron with a high energy. Which of the following is the reason why high energy is required? We want to investigate the structure. What is the reason why we need a high energy for a structure of nucleons? Basically, it's like we want electron diffraction, electron acting like a wave when we are observing the structure. So allow creation of a new particle. Allow creation of a new particle is correct, but not relevant to this question. Like particle accelerator, we accelerate to a very high speed so that we can create new particle. So this is valid, but not related to the explanation. Overcome the repulsive attractive but it will not have electrostatic repulsion. It will have attraction because a nucleon, neutrons, and protons are there. So protons will attract the electrons. To produce a relativist increase in the particle lifetime. So what will happen if we? It's not about the why it's not really, even if a relativistic effect is there, like the mass is greater for the particle, for the new particle, but it won't affect the lifetime. And to produce a short, because lambda is equals to h over mv, so if we accelerate to a very high speed, we produce a shorter wavelength, so that we can match the spacing of the like the structure of the nucleons and the spacing. So it causes a maximum diffraction. So producing a shorter wavelength is a main reason we use like electron microscope. We called to study the internal structure of the matter. So this was from June 2021.